in the next part of the problem. Now, I want to hit this point first before I go on and change this to grams per liter, which I'm sure you know how to do, but I'll do it here just to emphasize that. But we'll come back to this right here. In what I presented before this, we said that the solubility of strontium sulfate is 5.00 times 10 to the negative 4th moles per liter. Put that in a common ion of sulfate of 0.20 molar sulfate. We see that it drops to 1.25 times 10 to the negative 6. So how much did it drop? What was the loss of solubility? Well, we know it originally started with make sure I have the right number here. I had, 5 times 10 to the negative 4th moles per liter. And it went down to 1.25 times 10 to the negative 6 moles per liter. That whole thing, and we compare that to the original one, which was 5.00 times 10 to the negative 4th moles per liter. And we want a percentage out of that, we'll just go ahead and multiply that by 100. Now this is the loss of solubility. How much did we lose in solubility? And if you calculate that garbage out there, you get 99.8% loss. Why? Why did that happen? Well, let's go back to the two equations we had up here. This is the original equation that we're looking at here. But when you introduce sodium sulfate, you're dumping more sulfate into this. Okay? And what, according to Le Chatelier's principle, and this is an equilibrium situation, so Le Chatelier does come into play here. When you dump in substances on one side of the arrow, it's like building that castle, sand castle on the beach with your nephew or niece. And every time you keep dumping sand on top, it flows away. That's what's happening here. You're dumping more stuff on here, and it's going to flow away from it. So it's going to decrease the amount of X and push it more towards the crystal SrSO4 that will not dissolve. So how much actually dissolves, how much actually value for X will drop dramatically. How dramatically? Almost a complete 100%. Just, it won't ever be 100%, but that's pretty doggone close to it. Okay? Now, the last thing they want us to do is to find the solubility 1.25 times 10 to the negative 6 moles per liter. And again, I'll write it like this because we're going to have to do a little converting here. And I'm going to change this to grams per liter. So I have to change the moles here. So the moles go in the denominator to cancel out with grams on top. We go to the periodic chart, find strontium there. Looks to be 87.6 plus sulfur 32.1 plus 4 times 16.0. Okay, so what's that? 64, 96, 96, 184. Round off to nearest third significant figure there. So it puts that into my calculator. 1.25 e negative 6 times 184, and we get 2.30 times 10 to the negative 4th grams per liter. So if you have a liter of water and you dump in a chunk of sulfur sulfate, that's the number of grams that it's going to dissolve. Okay? So minute amount. This is why we call it insoluble. Is it insoluble? By definition, the word insoluble means does not dissolve at all. That's not true. Just a hint, so it looks like it doesn't dissolve, makes this an insoluble substance. Okay? Now, there will be other at least one other, I think there's two other problems that you're going to that you'll have to do, in which you're going to have to start, they give you grams per liter, and they want you to find the solubility or the value from that. And you know, for example, you take a look at number 35 in this text. There's a problem which they give you 0.016 grams per liter is the solubility of MgF2. And you can't work with that in a problem, so you're going to have to convert that right to moles. So you multiply that by and put grams at the bottom, moles on top. And this is going to be 24.3 for the magnesium plus 2 times 19.0 for the fluorine. So 38, that's 62.3 grams per 1 mole. And that's going to give you 2.57 times 10 to the negative 4 moles per liter. I'll put that back in capital M, so because you will have to show your labels of your setups as well. So that's how these problems are done. Not outrageously multi-step levels like we had with the titration problems, but enough to challenge you a bit. So your assignment for your practice problems is page 796, 34 through 38 even. Okay? Hey, have fun.